So hello everybody. Hi. Good evening andariki. Good evening. How are you all? So I hope andariki all of you are very excited for today's session kada. ఒకసారి చెప్పండి రా chat లో. How are you all? Good evening. Parimala, very good evening. Kerala Chari. So that means guys are doing well. అంతే కదా. So let us see. How many more are left? Hi. Hi everyone. Hi. Hello. So start చేద్దాం అందరికి చెప్పండి ఒకసారి. Shall we start? Yeah, Parimala, I'm also fine. Very good. Okay. Fine. So, hi MP40 King. Good evening all of you. Very good evening. And I'm doing great. Yes. Hi Little Moon. Hi Shiv Kumar. Other. Okay. There is some mismatch there. Okay. So let us start this session. చెప్పండి ఒకసారి. So ఈరోజు it is going to be kinematics 2D అంటే projectile motion related formula and మళ్ళీ ఒక simulation is also there. చూద్దాం అందరికి. Okay. Sorry, I'm having some. Okay. Hi Uday, good evening. Yeah, Shiva. Okay, Shiva. Got it. So students, ఇప్పటిదాకా we were only concerned about a motion in a straight line అంతే కదా. సో ఇప్పటి నుంచి we will be interested or we will be finding the path and the deviations when the particle leaves a straight line. Re. Hi. Hi everyone. Hi. No. Thank you so much. I'm not interested. Hello everybody. Hello. Hi. So everything clear kada? ఒకసారి చెప్పండి, is my audio and video all clear ra? Is my audio and video everything clear? చెప్పండి ఒకసారి. Am I visible and am I audible? Are you typing? I can't see it. Hi Deepika. Hi. Yes. Okay. Good evening all of you. So we will try to start this session. Okay. Hi Shalini. Hi. Good. Parimala. Very good. Kerala Chari. Good. So start చేద్దాం అమ్మా. చూడండి ఒక్కసారి. Okay. Great. Hey, great. Chalo. So, okay. Green screen. Endagura green screen. Can we change the color of it? We can't. Let it be. Hey, let us see. You have a pen option. It's a new studio for me. Okay. Completely new. Cannot say. Okay. So ఇప్పటిదాకా we discussed about a motion in a straight line ray అంతే కదా. We discussed about all the formulas. A is equals to dv by dt, v is equals to ds by dt and all those formulas. ఎప్పటి వరకు Hi Gitanjali. Hi. Yeah. So ఎప్పటి నుంచి we are interested to talk about a motion in two dimensions. Two dimensions అంటే ఏంటిరా? టూ డైమెన్షన్స్ అంటే ఏంటి సార్? టూ డైమెన్షన్స్ అంటే పార్టికల్ విల్ హ్యావ్ మోషన్ ఇన్ అ కాంపోనెంట్స్ రే, కాంపోనెంట్స్ రే. యా పరిమళ, ఇట్స్ నాట్ ఇన్ మై హ్యాండ్స్. ఓకే, అరే ఎలా చేంజ్ చేయాలిరా ఈ సెట్టింగ్స్? కోడ్ అరే would not happen something else. Okay, calendar is there re, but not in my hands re. Adjust చేసుకోండి. Not more slides are there. ఒకటే స్లైడ్ ఉంటుంది, దాని తర్వాత we do have our own slides ra. So I don't know if change the color of the screen. Kani, let it be. So sir, here we will be discussing about, it's not in my hands re baba, screen color is fixed. For this it is fixed, so I can't change it. Okay, so kinematics 2D lo point number 1, we will be studying about a motion that is extended over multiple axes ra. Okay, so motion of a particle what should I say re? extended ra, extended beyond a line. అంటే ఏంటిరా నాకు చెప్పండి అందరికి ఒక్కసారి. I will tell you a few examples of motion. You tell me if it's a linear motion or if it's a motion in a plane. Okay, 1D motion or 2D motion. చూసుకోండి అందరికి. A particle is there. It is moving something like this ra. చెప్పండి 1D 2D ra. Hey, 1D 2D ra. 1D or 2D? Sir, 1D. Similarly, particle moving like this ra. చెప్పు 1D 2D ra. 1D or 2D? It is also 1D. What is the understand the setting of? Okay, sir, it is 1D motion, sir. Okay, re. Ante whenever the particle is moving in a line, we call it 1D motion. Ante kada? Not 2D re. Hey, not 2D. Who is saying 2D? It's not 2D. It's 1D only re. It's 1D only. Chuskondi andariki. What about this motion, sir? It is also 1D re. It is also 1D. So andariki చూసుకోండి, these are all the 1D motion. అంటే motion in a straight line, అంతే కదా? Yes, 1D motion అంటే ఏంటిరా? Motion in a straight line. ఇప్పుడు చూసుకోండి, my particle is moving something like this. It's not a straight line కదా? Yes, it is not a straight line. అంటే this motion will be 2D motion. ఇప్పటి నుంచి గుర్తుపెట్టుకోండి, ఎప్పుడైనా my motion is leaving the line ray, leaving the line, what I will say? I will simply say it is a 2D motion, something like this ray. Okay, and something like this ray. Okay, good. So all these types of motions, they are 2D motions. Chuskondi, it is the path. Okay, hey, it is the path of the motion ray. Hey, it is path, and this path is 2D motion. Nandini, it's by default green board. Okay, చూసుకోండి. There are some black slides also, don't worry. Okay, there are black slides also. Good. Keralachari, good. Spandana, good evening. Okay, so 2D motion ante entira? Whenever the particle is leaving a straight line, I will call it a 2D motion. Ante kada? Okay, next చూసుకోండి రే. Now ఇప్పుడు I have to resolve. Okay, ఇప్పుడు నాకు వెలాసిటీ గురించి మాట్లాడాలిరా. How will I talk about the velocity? చూసుకోండి అందరికి చూసుకోండి. So if I am talking about the path, and if I am talking about the velocity ra. Okay. Yes. Hey. How to do the settings ra? Writing board, not writing board. I don't want this ray. I don't want this ray. Gone. Writing board is there, browser is there, subject is there. Okay. Happy now. Alright. Happy now. Okay, good, good, good. Okay, okay. You want me to change the color of this also? Okay, okay, change it. Choose. So go to color, subject, black. Right, black. Ante. Good. Approach. Hey, subject, color, black. And you can't see these lines, right? You know, then I will have to change the color of these lines. So these are my 1D motion, right? Hey, 1D motion, right? How can I say? Yes, this is also, and it is a separation line, right? Chuskondi andariki. So it is 1D motion, ante kada? Okay, good. Chuskondi. Okay. I know. Chalo. Hey, so ఇప్పుడు we will talk about the velocity. Hey, speed of the particle. Velocity as a vector, ante kada? So we will talk about velocity of a particle as a vector. Ante kada? Good. So if my path is like this, చూసుకోండి. You do have circular motion in this also, okay? So ఇదే chapter లో we will also talk about the circular motion, ante kada? Good. చూసుకోండి. So this is my path. Hey, this is my path. Sir, what is the difference between a path and speed? Velocity. To be honest, what is the difference between path and speed, sir? Sir, velocity changes the path. Velocity changes the path. Okay, so sir, this is my car, sir. Idi na car. So I'm talking about not like this, right? Okay, not like this. Okay, so this is my car, or it is, let us say this is an object of some mass, a random object. Okay, random object. So ఇప్పుడు ఏం చేద్దాం దానికంటే we will do one thing. We will give him the velocity in this direction, రా. ఏమైతది? If I give the velocity in this direction, that means the particle will move in this direction also. So అంటే కొంచెం సమయం తర్వాత the particle will come here, రా. అంతే కదా? So దాని తర్వాత I am giving the speed in this direction, రే. చూసుకోండి. It is my velocity v1. ఇదే నా velocity v2, అంతే కదా? So v2 ఇచ్చిన తర్వాత చెప్పండి అందరికి ఏమైతది? I can simply say the particle will now come to this direction. Ante if it is leaving a straight line, చూసుకోండి అందరికి. If it is leaving a straight line, ante ఏంటిరా? Ante the velocity vector is changing, ante kada? Yes. So if you are having continuously changing velocity vector direction, automatically the direction of the particle also changes. Are you understanding? So I will take a very general case now and discuss చేద్దాం అందరికి. చూసుకోండి. So imagine here at this point, there is a tank ante telusa? Tank or cannonball, ra. Cannonball telusa andariki? Okay, thank you so much, Nandini. Good. Arav, very good. Path is the actual route taken to travel between 2 points. Kani path this depends completely on the velocity. చూసుకోండి అందరికి. If you have a velocity in a single direction, రా. So మీ velocity ఒక single direction లో ఉంటే the path is also a straight line. కానీ if your velocity is changing the directions, I'm not talking about magnitudes. I am not talking about magnitudes. నేను good Parimala, good. Okay, so I'm only talking about the direction, రా. అందరికి చూసుకోండి. So if this is my cannon, a ball is thrown, ray. A ball is thrown. So ఏమైతది sir? The ball will go up and then it comes down, ante kada? It is the final case that we have to discuss, ray. Okay, it is the final case that we have to discuss. కానీ చూసుకోండి. ఇప్పుడు I'll talk about the velocities. Okay, velocity. ఎప్పుడైనా you want the velocity of a particle moving, ray. Hey, whenever you want a velocity of a moving particle, you just draw a tangent, ray. small tangent. చూసుకోండి. ఆ పాయింట్ లో వెలాసిటీ కావాలంటే డ్రా టాంజెంట్, సంథింగ్ లైక్ దిస్. ఇదే నా వెలాసిటీ వెక్టర్. ఓకే సార్, ఈ పాయింట్ లో వచ్చి వెలాసిటీ కావాలంటే ఇక్కడ కూడా డ్రా చేసుకోండి టాంజెంట్. హియర్ ఆల్సో ఇఫ్ యూ వాంట్ ఇట్, డ్రా టాంజెంట్, అంతే కదా? సో అంటే ఏం అర్థమవుతుందిరా? దాట్ మీన్స్ velocity vector is changing the direction, ante kada? I'm not concerned about the magnitude. I am not concerned about the magnitude. Okay, I'm not concerned about the magnitude. Velocity is not zero. Hey, velocity is not zero. So చూసుకోండి point number one, path change, hey, path change happens when only when the velocity is changed. Velocity direction, better you write direction. So velocity direction is changed. ఇప్పుడు ఒక చాలా పెద్ద క్వశ్చన్ రా, who is changing this direction of velocity? Who is changing the direction of velocity? Who is changing the direction of velocity? Acceleration రే చూసుకోండి, acceleration is changing the direction and value of velocity. Ante, these are only the 2 points ra, చూసుకోండి. ఎప్పుడు I also have to discuss about few more points, కానీ we will discuss it later on రా. ఎప్పటిదాకా అర్థమైంది అందరికీ చెప్పండి. గుడ్ ఆరవ్ గుడ్. ఫోర్స్ అంటే యాక్సిలరేషన్ కదా, యాక్సిలరేషన్ ఇస్ ఫోర్స్ బై మాస్ ఓన్లీ రే. ఫోర్స్ అంటే యాక్సిలరేషన్, యాక్సిలరేషన్ అంటే ఫోర్స్, అంతే కదా. గుడ్, వెరీ గుడ్, వెరీ గుడ్, గుడ్. సో ఐ విల్ see about 3 different instances of velocity. అందరికీ చూసుకోండి, I will see about the 3 instances of velocity. So let us say the particle or the ball, the ball is thrown something like this ray. It is thrown something like this. ఏమైతుంది, when you throw it, it will go up and then it will come down, అంతే కదా. సంథింగ్ లైక్ దిస్ రా. ఒక కర్వ్డ్ పాత్ తీసుకున్నారు, చూసుకోండి. సో దిస్ ఇస్ మై పాత్. సో ఈ పాత్ లో ఐ am interested to find the speeds at some particular locations. చూసుకోండి, here is my initial point, అంతే కదా. సో ఇక్కడ నుంచి I am throwing the ball కదా. సో this should be the direction of velocity at t is equals to 0 రే. చూసుకోండి అందరికి, this should be the direction of velocity, this, something like this. Okay, good. So this should be the direction of velocity. Good. Okay, so what we do now is we try to see the velocity ray, that it is not in x direction or it is not in y direction sir. చూసుకోండి, velocity is not in x direction, also it is not in y direction, అంటే the velocity is between them kada. So what can we do ray? We can resolve the vector. Hey, velocity is a vector, so what we can do now, we can resolve this vector. చూసుకోండి, so the first component will be here, the second component will be here, ante kada. Are you understanding? The first component is right, the second component is in the upward direction, ante kada. So now the total game of projectile or the total game of this 2D motion is depended on these 2 components. It is in the x direction, దీని కోసం it is in the y direction, అంతే కదా. Vx and vy. You change Vx and Vy, automatically the value and the direction of the net velocity changes, అంటే automatically it will take a curved path. అర్థమైంది? ఇప్పటి వరకు అందరికి చెప్పండి. So till this point there is no doubt sir, whenever we are throwing an object, point number 1, it only changes path when its velocity is changed. Point number 2, velocity will only change when there is acceleration. ఎప్పుడు ఎలా చేంజ్ అవుతుంది అంటే, we are going to break down this velocity into 2 components. దాని తర్వాత we will be observing the process. Good, పరిమళ, very good. ఎప్పుడు let us come to prerequisites రా. సో ఇప్పుడు I want to talk about vector resolution, అంతే కదా. Good. So vector resolution అంటే, if I have a vector in this direction, చెప్పండి, where do the components form? The first component is in the right side, second component in the upward direction. చూసుకోండి, if the value of this vector v and its angle is theta రా, చెప్పు value of this component vx, చెప్పండి vx is equals to v into cos theta, అంతే కదా. ఎందుకంటే సార్ it is an adjacent component. Okay, good. and it is the remaining component, automatically it comes out to be v sin theta. Okay. ఇప్పుడు చూద్దాం రా. Next. This is my velocity vector. అందరికీ చూసుకోండి. This is my velocity vector at any random point. Okay, చెప్పండి components రా. Components. The first component will be towards the left. The second component will be towards the upward direction. అంతే కదా. ఈ యాంగిల్ ని ఆల్ఫా పిలుస్తే let us say the velocity now is v2 రా. v2. చెప్పండి components కి values చెప్పండి. Automatically it will come out as v2 cos alpha. This comes as v2 sin alpha. అంతే కదా. Only addition that we do is, if this vector is in x direction అంటే తెలుసా, horizontal ఉంటే we call it as vx, and vertical ఉంటే we call it vy. అంతే. That is the only difference in it. Okay, good. Next scenario చూసుకోండి. If my speed is in this direction, చెప్పండి the direction of the components. So sir, the direction of the components will be here and here. Which is vx and which is vy రే? Horizontal component is always vx, vertical component is always vy. ante kada. Good evening Maitri. No problem. So let us say the value is v3 ra. ఈ angle ante I am giving this angle now. Okay, this angle beta రే. చెప్పండి horizontal component kada. Horizontal component ante x component. Are you understanding? Good evening. So this automatically becomes v3 cos beta and v3 sin beta. ante kada. Yes. చెప్పండి last scenario lo let us say my speed is something like this ra. v4. So components గురించి చెప్పండి రా. The first component is in the downward direction, the second component is in the right side. అంటే horizontal vx ఇదే, vy ఇదే. Finished. So if I am giving you this angle as delta, చెప్పండి అందరికి. So it will come out as v4 cos delta and v4 sin delta. అంతే కదా. Good. So these are the basic things that you are expected. చూసుకోండి. A force of magnitude 100 Newton is applied at an angle of 60 degrees with the horizontal on a block of mass 12.5 kg. So నా దగ్గర ఒక 12.5 kg block is there. 12.5 kg. ఆ block పై there is a force acting of magnitude 100 Newton. చూసుకోండి అందరికి. At an angle of 60 degree with the horizontal కదా. So ఇదే నా horizontal. ఈ horizontal తోనే 60 degree angle it is making. అంటే చెప్పండి what will happen రే? What will happen? చెప్పండి అందరికి. What will happen? Good. Very good. అంటే we will now resolve రే. ఇప్పుడు resolve చేద్దాం ఈ force ని. So the first component same color కదా. I don't want the same color. Okay. So the first component will be towards the right side. Second component towards the upward direction. So it is 60, 100 అంటే 100 into cos 60 automatically. చూసుకోండి 100 into cos 60 అంటే 100 into 1 by 2 కదా. So అంటే 50 Newton force is acting in the right side రా. చెప్పు పైన గురించి చెప్పండి. So you can simply say sir it is 100 into sin 60. Directly write the value. It is coming out as 50 into root 3 Newton. అంతే. So it's a smooth surface kada. So the block will only move towards the right side. Net force is equals to 50 Newton ra. No, force is equals to 50 Newton. Ippudu apply cheskondi formula. F is equals to m into a. Ante kada. Force is how much re? 50. Mass gurinchi cheppandi 12.5 into acceleration. So ikkada nunchi acceleration is 50 divided by 12.5. Ante 4 meters per second square in the right side ra. Okay. Are you understanding about the vectors? Very good. Very good. Next, an object of mass 10 kg thrown at a speed of 10 root 2 at an angle of 45 degree with the horizontal. Find the momentum of the object in horizontal and vertical ra. Chuskondi. Object of mass 10 kg kada. So ide na object of mass 10 kg andariki chuskondi. It is thrown at the speed of 10 root 2 meter per second. Something like this ra. So 10 root 2 meter per second. Ante kada. How re? How? At an angle of 45 degree with the horizontal ray. Horizontal draw chuskondi. So it becomes automatically 45 degree. Ante kada. ఎప్పుడు resolve చేసుకోండి, resolve the vectors రే. The first component will be towards the right and second is in the upward direction. అంతే కదా? Good. Arav, very good. So you can simply say, sir, the speed in the right side is equals to v into cos 45. ఎందుకంటే adjacent component రే, v cos 45, v sin 45, v is 10 root 2 into sin of 45. ఎప్పుడు cos 45 is 1 by root 2, sin 45 is 1 by root 2, అంటే 10 root 2 into 1 by root 2, root 2 gone. So only speed is 10 meter per second horizontal రే. Even if it appears to you that, చూసుకోండి అందరికీ చూసుకోండి, even if it appears to you that the speed is 10 root 2 in this direction, అంటే it is made up of two different speeds. అర్థమైంది? Two different speeds. First in the right side, second in the upward. అంటే it is also equals to 10 meter per second. I hope it is audible and understandable అందరికీ. So you can simply say speed is 10 and mass is 10. అంటే px is equals to mass into speed in the horizontal x direction. X direction లో speed చెప్పండి. So it is equals to 10 into 10 అంతే కదా? సో అంటే 100 kg meter per second. అదే same momentum in the y axis also. So p is equals to 100 అంతే. py is equals to. Finished? Next. Represent the vector 3i plus 4j in the geometric form రే. చూసుకోండి ఇదే నా వెక్టర్. So let us call a bar is equals to 3i bar plus 4j bar అంతే కదా? So that means one vector is in the right side, other vector is in the upward direction. చూసుకోండి 3i is something like this అంతే కదా? What about 4j రే? 4j looks something like this. Oh sir, very good. So ఇప్పుడు ఏం చేయాలి? ఇప్పుడు take the resultant. Resultant ఎలా తీసుకోవాలి రా? Resultant is always between the two vectors something like this. So ఇదే నా వెక్టర్ రే. So this is my vector a bar is equals to 3i bar plus 4j bar. అంతే కదా? Next. చాలా ఇంపార్టెంట్ స్టేట్మెంట్స్ రా, చూసుకోండి. That perpendicular vectors do not interfere with each other. Very good. Arav, very good. The perpendicular vectors do not interfere with one another. What do you mean by this statement, sir? So you imagine you have one object, ఒకటే ఆబ్జెక్ట్స్ ఉంటుంది, కానీ ఆ ఆబ్జెక్ట్ పై రెండు డైరెక్షన్స్ లో వేరే ఫోర్స్ యాక్ట్ చేస్తున్నారు. I hope you are understanding రే. Okay, so for example, let us take this question రే. It will explain you more with a more clarity. Okay, చూసుకోండి, read the question first. An object of mass 10 kg moving with a speed of 4i meter per second. So నా దగ్గర ఒక 10 kg block is there రే. చూసుకోండి, 10 kg object is there moving towards right రా. ఎందుకు రైట్? 4i cap కదా? i cap is always in the right side. Good. Okay sir, speed is equals to 4i cap meter per second అంతే. Good. Experiences of force of 20j రా. 20j రే. Force అంటే it is acting in the upward direction now. So F is equals to 20j Newton. అరే, speed in the x-axis, force in the y-axis. అంటే they are perpendicular directions కదా? Yes. So the directions are perpendicular. What do you understand by this? So if the directions are perpendicular, the effect of this force will only be in this direction, vertical only. It will not do anything in the horizontal. ఎందుకంటే horizontal లో there is no force at all. అందరికీ అర్థం చేసుకోండి. That's what I'm telling to you. Whenever you have two different perpendicular directions, everything in independent direction works independently. అంతే కదా? Are you understanding? Good. So what is it asking? The horizontal speed and the total speed after 4 seconds. అడుగుతున్నారు, చెప్పండి. Sir, horizontal లో speed is there, but horizontal లో force is not there. అంటే horizontal లో speed is there, but force is not there. అంటే the speed will remain constant రే. We did not discuss. We discussed. Okay, so we discussed kada? Yes, we discussed. What did we discuss? We said that whenever, very good, Arav, very good. So whenever you have a speed and no acceleration, ante speed will remain the same, ante kada? So you apply the same in two different axes ra, along x-axis also, along y-axis also. Chuskondi, along x-axis, no force, no acceleration, nothing will change, everything will remain same. So this force ray, it is there, but it is in the vertical direction. It will not interfere with the speed in the x-axis. So everything goes on independently. And ardhamaindi kada? So 4 seconds tarvata cheppandi in the x-axis ra, in the x direction, cheppandi andariki, in the x direction, speed is equals to, final speed is equals to initial speed, ante that is equals to 4 meter per second Vx. Ippudu we will talk about the twist ray. Okay, in y direction, cheppandi andariki, y direction lo what happens in the y direction ray? What happens in the y direction? Sir, speed is not there. Chuskondi, initial speed there ray, not there kada? In y direction there is no speed at all, right? So if there is no speed but there is acceleration ray, okay, so f in the y direction is equals to 20, mass is 10, ante acceleration in the y direction is equals to 20 by 10, 2 meters per second square, ante kada? Acceleration is there ray. So acceleration unte the speed will change, the speed will increase kada? Yes. So v is equals to u plus at. This equation will be applied completely in the y direction. Endukura? Endukante acceleration is only in the y direction. So ekkadi nunchi u is 0, acceleration is how much? 2 into how much time? 4 seconds, force. So it is equals to 8 meter per second. So idena speed in the y direction, ante kada? So vy is equals to 8. Net speed is equals to vectors ray, 4 meter per second in the right, 8 meter per second in the upward direction, ante kada? So what will be the net speed ray? Net speed is equals to root of vx square plus vy square. So Maitri, I don't look good on other days, huh? So it is 4 square plus 8 square, ante kada? So that is directly equals to root 80 ra. Finished? Good. Next, thought experiment. Now I want all of you to focus, okay? I want all of you to focus on this explanation. Ardham cheskondi andariki. So if I have a car, this car is visible to all of you. Yes. So this car is visible and this car is moving with a constant speed v ray. Chuskondi. This car is actually moving. This car is actually moving with a speed of v. Constant speed kada? Constant speed. But there is a monkey sitting on this car ray. Okay. There is a monkey sitting on this car. So ఏమైతది అంటే this monkey takes a jump only in the vertical direction. Chuskondi. So let us say the monkey takes a jump only in the vertical direction. So let us say velocity of the car, velocity of the monkey. ఏమైతది రా? ఏమైతది? So if I am walking at the same time I am throwing something upwards. Chuskondi. Hey, you have two different frames of reference kada? You have two different frames of references. Chuskondi. If I am throwing this pen, not this pen, right? It's a very valuable thing, okay? So let us say, hey, this pencil is visible to all of you. Is it visible to all of you? Okay, yeah, it's visible, okay? It's visible to all of you. Just continue. So what I'm doing now is, just continue. I'm throwing this directly upward direction and catching it. Coming in my hand only, ante kada? So ippudu em chestamante, chuskondi. Now I'm throwing it. Throw chasina tarvata I'm walking in the forward direction. Chuskondi andariki. So I throwed it and I walked in the forward direction. So where did it fall? Behind me. But ippudu let's mix both the scenarios. So what I'll do now is I'll walk and at the same time throw this pencil, okay? So I'm walking and throwing. Chuskondi. So what I'm doing, I'm walking and then throwing. Are you understanding? I'm walking and throwing. So when I'm walking and throwing, it is not falling back ray. Hey, hey, so ante when this car is moving at the same time the monkey is jumping up, ante this monkey will always be below the car only. Whenever he will always be above this car only. Chooskondira. So idena car and he will jump exactly on the car. Ante kada. Why re? Why re? Because inertia. Are you understanding? Are you understanding, all of you? So if you have something that is walking and at the same time you are throwing it in the upward direction, this particle will not just move in the upward direction, right? It will also move in the horizontal and at the same time upward direction. So rendu vere velocities unnai kada. Good. Similarly, let us see this experiment. Cheppandi. Hey, em chestunnaro video? He is simply releasing the ball kada. He is simply dropping the ball. Hey, he is simply dropping the ball. Ekkada vachi he is throwing the ball. And here he is simply dropping the ball. Hey, the ball was here, okay. Initially the ball was here. Cheppandi, time gurinchi cheppandi. What can you say about the time when these two balls hit the ground, ra? They'll take same time or they'll take different time, ra? Cheppandi andariki. They will take same time or they will take different times. So when you throw these balls, they will take same time to fall or they will take different times. Sir, this ball is traveling more distance kada. It is traveling this much and this much, re. This much distance. But this is not traveling much distance. It is falling here only, ra. And this is falling there, re. Here. So it is traveling much distance. Until it will take more time kada. Good. Good, Josna, very good. Same time. Okay, same time. Endukante they do have same force acting in the vertical direction. Directions is different, ante kada. Not different time, parimala. Same time. Okay, same time. Endukante they do have the same force. Hey, we are talking about time to fall down kada. Which direction are we interested in? Vertical. అంటే వర్టికల్లో ఒకటే ఫోర్స్ ఉంటుంది కదా, గ్రావిటీ ఫోర్స్ రా. చూసుకోండి, అంటే యాక్సిలరేషన్ డ్యూ టు గ్రావిటీ ఇట్ ఈస్ ఓన్లీ దేర్ ఇన్ ద డౌన్వర్డ్ డైరెక్షన్, అంతే కదా. ఎస్, సో దాట్ మీన్స్ ద టైమ్ దే విల్ టేక్ విల్ ఆల్సో బి సేమ్. ఐ హోప్ ఇట్స్ ఆడిబుల్. ఓకే, దే విల్ టేక్ ద సేమ్ టైమ్ ఇర్రెస్పెక్టివ్ ఆఫ్ హౌ ఫాస్ట్ హీ ఈస్ థ్రోవింగ్ ఇన్ ద హారిజంటల్. ఎందుకంటే హారిజంటల్ స్పీడ్ it does not affect vertical speed. Understanding? And the time to fall down, right, is directly dependent on the vertical speed only. Good. Great. Okay. So this is also one more experiment, ra. Visible andariki chuskondi. So what is happening now is na daggara oka cannon ball untundi ra. I hope it is audible to you. Okay, let us take black color, not black color, let us take red color. So ide na cannon ball, okay, and there is this monkey sitting on this tree, ante kada. There is this monkey that is sitting on this tree. So what I have to do is, first case lo, as soon as the cannon is shot, there is a chance that after listening this firing sound, the monkey simply releases his hands and falls down. అందరికీ అర్థం చేసుకోండి. ఫస్ట్ కేస్, వాట్ ఈస్ ద ఫస్ట్ కేస్ రే? యాజ్ సూన్ యాజ్ ద షాట్ ఈస్ ఫైర్డ్, మంకీ రిలీజెస్, ఫాల్స్ డౌన్. పాయింట్ నెంబర్ 1. కేస్ నెంబర్ 1. కేస్ నెంబర్ 2, మంకీ డజంట్ డూ దిస్. అంటే ఫైర్ చేసిన తర్వాత కూడా ద మంకీ ఈస్ జస్ట్ హ్యాంగింగ్ ఆన్ ద ట్రీ. సో మై క్వశ్చన్ ఈస్, ఫస్ట్ కేస్ అంటే మంకీ where will you target, Ray? You have to hit this monkey, this bloody monkey, okay? You have to kill it. So how will you hit? Where will you put the target? Chuskondi, cheppandi andariki. Where will you put the target in first case? First case enti ra? As soon as you are firing this cannon, the monkey is releasing the hand. where will you take the target in the first case? Cheppandi andariki. Hi, hello Jaswant, hello. Did you understand this? So good. Hand, not hand. Okay, hand. Okay, good. You are taking the target on hand only. So as soon as you hit the target on the monkey only, monkey release the hand, ante kada. So monkey is falling only under the gravity. Chuskondi. Monkey is falling under the gravity kada. So that means if the bullet goes and hits here, monkey is no longer here. Monkey is falling down, ante kada. So it will miss the shot. But if the gravity is acting on the monkey, if the gravity is acting on the monkey, okay, if the gravity is acting on the monkey, at the same time the same gravity is acting on the ball also kada. Yes, that means both will have same motion in the vertical direction. Chuskondi. Are you understanding? Yes, arrow, innocent monkey. Yes. So they are having same motion in the vertical direction. Ante sir, I must hit it on monkey only. Are you understanding? Good. Next scenario, in the next scenario, monkey does not release hand. Ante deaf monkey deaf monkey, okay, deaf monkey. Cheppandi. If the monkey is deaf, where will you target? Where will you target? Cheppandi. If the monkey is not releasing the hand, where will you hit or where will you take the target such that it should hit the monkey? Cheppandi andariki. Where will you target the monkey such that it must hit the monkey only? So can I say, if I am just shooting on the monkey only, if I am shooting on the monkey only, but what happens? Due to the gravity, the ball falls down. Okay? But there is this gravity acting, G acting. G acting, on this ball, G is acting down until it will miss it. So goes something like this. Are you understanding? So that means I must take my aim at a little higher point, not head. This is my correct aim. Chuskondi. If I am taking the aim here, the ball should go something and hit the monkey. Endukante the gravity is acting, so the gravity also pulls it down. No, are you sure? Monkey is not releasing himself, okay? Monkey is not releasing himself, arrow. If you are talking about the monkey's initial position, here is the initial position. So this is my initial position aim, initial position aim. So what happens is the bullet will not go exactly in the same way. The cannonball, it has gravity kada, so it will fall down. Vertical motion also happens for that cannonball. Are you understanding? So you cannot say to take the aim at the monkey's initial position. You must aim a little higher, here. Take the aim here. If you are taking the aim here, the bullet will actually go down and hit the monkey, something like this. Hope it's understandable. Okay. Next. Okay. It's a very famous experiment, okay, actually. Now, I want all of you to imagine this scenario. Chuskondi. This is a student riding a bike. So while riding only, it can be asked very precisely in your examination, okay? It could be asked very precisely in your examination. I have literally done this experiment multiple times while teaching this, okay? I have done this. Cheppandi. So while riding the bike, he throws the ball vertically upwards. Andarki chuskondi. While riding the bike only, he throws the ball vertically upwards. So now the question is, chuskondi. I'm telling you again. So what did he do? He was riding the bike, and at the same time, when the bike was in motion, he threw the ball up. and throw chesi, immediately he is applying the brakes. Hey, చూసుకోండి. And after throwing, he is immediately applying the brakes. చెప్పండి, where will the ball fall? This is the final scenario. చూసుకోండి, final scenario లో where will the ball fall? Behind him, above him, or exactly on his head? Position number 1, position number 2, position number 3, where will the ball fall? Yeah, అదే గీతాంజలి, but where it will fall down, but where? చెప్పండి అందరికి, where will the ball fall? Position 3, not back of the ball. చూసుకోండి. So what's happening here, you have to understand the motion is having two different components. First component, as soon as I am throwing the ball in the upward direction, చూసుకోండి, my cycle or my bike has some speed kada. Let us say the speed is v. అందరికి చూసుకోండి, ఈ speed is, I'm calling this horizontal speed as v. Let us say this speed is u. Okay, this speed, or let us do one thing simply, let us say vx and this is vy. ante kada. So emaitadi ante, the ball as soon as it is thrown as soon as the ball is thrown it has two different speeds. First speed is vx, same speed as the speed of bike. చూసుకోండి, same speed. The second speed it is having is vy, ante speed in the upward direction. ante kada. ఇప్పుడు చెప్పండి నాకు, హారిజంటల్ అండ్ వర్టికల్ రెండు డైరెక్షన్స్ ఉన్నాయి కదా, నాట్ వన్ ఇస్ ద రాంగ్ ఆన్సర్. అందరికీ చూసుకోండి, హారిజంటల్ అండ్ వర్టికల్ ఆర్ ద పర్పెండిక్యులర్ డైరెక్షన్స్. పర్పెండిక్యులర్ డైరెక్షన్స్. అండ్ వాట్ డిడ్ వి డిస్కస్? What did we discuss? We said that the perpendicular vectors do not interfere అంటే హారిజంటల్లో ఏమి ఫోర్స్ ఉన్నాయి, నో ఫోర్స్ ఇన్ ద హారిజంటల్, అంతే కదా. అంటే ద స్పీడ్ ఇన్ ద హారిజంటల్ రిమైన్స్ ద సేమ్. చూసుకోండి, ద స్పీడ్ ఇన్ ద హారిజంటల్ రిమైన్స్ ద సేమ్. కానీ వర్టికల్లో స్పీడ్ vy ఉంటే ద యాక్సిలరేషన్ g is acting in the downward direction, అంతే కదా. సో యూ బ్రేక్ దిస్ మోషన్ again I will tell you, you break this motion. Okay, good evening Isha, very good evening. So what you do now is you break this motion into two parts. The first is the horizontal and the second is the vertical part, ante kada. So you break this motion. So sir, the speed in vertical direction, it is just like going up and coming down, ante kada. Cheppandi, the speed in the vertical direction, it is just like going up and coming down, ante. But what about horizontal? Horizontal speed remains the same. Chuskondi, vx remains the same. Ante when the rider was somewhere here, should I draw it? Something like this, something like this. So this is my rider. When the bike was something here, the speed of the bike was v, same speed kada, vx, and the ball will be exactly above the person having speed vx only but some speed in the vertical also. Eppudu this breaker is applying brakes, this biker is applying brakes apply chesi, his speed becomes zero kada. Yes, so v becomes zero in the horizontal. Kani the speed of the ball is not becoming zero, endukante no force in the horizontal direction on the ball kada. So ball will keep moving as it is. Are you understanding? So speed of the rider in the horizontal is zero, but the speed of the ball is not zero, right? So it will go and fall on the third position, something like this. Are you understanding? Good, very good. Yes, great. అర్థమైంది అందరికి, చెప్పండి ఒకసారి. I hope you understood it, right? Good. So if you are understanding this, that means you will understand projectile. If you don't understand this, that means you will be facing huge problems in understanding projectile also. Okay, good. Okay, Srinivas, I will explain you once again. Chusko. So as soon as, let us imagine this is my car, okay, car. Now I'm telling about car. A car, there is a tank. The tank is actually shooting the ball in the upward direction, something like this. Ante kada? The car is actually moving towards the right side. Chuskondi. But with a speed v, with a speed v or vx, you can say vx. Vx. Vx is the speed of the car. Car nunchi you are throwing a ball with a speed vy. Ante kada? Ippudu ball gurinchi cheppura. Ippudu ball gurinchi cheppu. What happens to the ball, re? So this ball, as soon as it is thrown up, it has two different speeds, ra. First speed is vx in the horizontal and second speed is vy in the vertical. Ante kada? Are you understanding? The second speed is vy in the vertical, first speed is vx in the horizontal. What is happening now is this vx horizontal, vy vertical, ante two perpendicular directions unnai kada. Are you understanding? So this motion will not be affected. Ante whatever happens in vertical, it will not affect horizontal, and whatever happens in horizontal, it will not affect vertical. Ante kada? Very good, very good. So now the ball is having same speed as vx. So is vx changing, ra? Is vx changing? No. How? To change the speed, we need force, re. Is any force acting in the horizontal? No force kada. So it will remain the same. But vertical lo chuskondi. Vertical lo there is gravity, re. Hey, mg acting on the ball kada. So this mg will change this vy. Ante kada? This mg will change this vy. So that means the vy will first increase, become 0, then become negative. Understanding? But remember, all the times vx is remaining same. Ante kada? Vx is always remaining same, ra. Hey, same, ra. So what's happening? This ball will go something like this. Endukante it is going in the right also, it is going in the up also. So right up. When you take it, the motion becomes something like this, ra. Good. Very good. Aro. Very good. So koncham samayam tarvata, when the car is applying the brakes, re, when the car is applying the brakes, cheppo, initially it had vx, brakes apply chesina tarvata, the speed becomes 0 kada. So ippudu vx is 0, re. Kani. The horizontal speed of the ball is not 0. Why? Because there is no force on this ball, so the ball will keep on moving towards the right. Endukante it has horizontal speed also. Understanding? So due to the speed, the ball will go something like this and it will fall in front of the car. 2D. Not 1D. 1D అయిపోయింది కదా. Good. సేమ్ ఎక్స్పెరిమెంట్స్ రా. ఎప్పుడు టైం కన్స్ట్రెంట్స్ గురించి మాట్లాడతాం. చూసుకోండి. 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 So as soon as the ball is thrown, we are trying to resolve the motion into two directions. Ante kada? So let us say the speed of the car, speed of the car ni we will say it as vx. Ante kada? And the speed of the ball we will call it as vy. Hi Ahan edits. Hi. So the speed of the ball, hi Ahan edits. Hi. The speed of the ball we will call it as vy. Endukante it's in the y direction. Ante kada? Now chuskondi. Observe, whatever time, okay, you understand, if you are able to understand, does this make sense? Cheppandi. If you are able to understand this, you tell me, okay. Vy is there kada? Ante vertical lo oka speed untundi. At the same time, there is acceleration due to gravity in the downwards direction. Ante kada? So that means there is acceleration also, re. Ante vertical, only vertical lo chusi, it is not possible for us to break down this motion by a normal human eye, okay? By a normal human eye it is not possible, but you understand, the ball will move with the car and at the same time it will land on the car only. Ardhamaindi andariki? The car is moving something like this. The car is moving something like this and the ball is moving something like this, right? But ultimately they are meeting at the same point. Hi, Naruto, hi. Okay, so the car is moving something like this, but the ball is moving something like this, okay? Ultimately they are meeting at the same time. Ante, chuskondi. The ball now, it is going up also and coming down also. Are you understanding? The ball is going up also, it is here, right, initially. So it is going up also here, and up nunchi it is also coming down. Are you understanding? Hey, who is crying? Who is crying? Okay. At the same time, the ball is also moving forward. Are you understanding? At the same time, the ball is also moving forward. Kani, you observe it. I'm telling about very important thing, okay? It is a very important slide. Andariki observe cheskondi. Cheppandi, time gurinchi cheppandi. Can I say the time taken by ball to go up and come down? Hey, let us say 10 seconds. So in 10 seconds, the ball went up and came down. Ide 10 seconds low. Can I simply say that the ball has also moved this distance? Only in the 10 seconds only. Chuskondi. Not area. Not area. Are you understanding? So, in only these 10 seconds only, the ball is moving up also, coming down also. Ide 10 seconds low, the ball is also covering the horizontal displacement. Are you understanding? Okay. Okay, good. 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 Rakesh, good. Good. Congratulations. Ippudu we'll talk about projectile wrap. Chuskondi. In a projectile motion. Good. Very good. Bhanu, very good. First, it will ascent and then it will descend. Good. Hey, what is happening here? Chalo. Good. So, if I have a ball, hey, chuskondira. So this is my ground, ante kada? Yes, this is my ground. This is my ground. From this ground, I am throwing this ball something like this. Andariki ardham cheskondi. So the ball, it will go up and it will come down. Ante kada? Same motion as the football. Same motion as that of football. Ante kada? Yes. So, if the speed is v, u or let us say initial speed u kada? Yes. So, if the speed is u, andariki cheppandi. First, tell me about the components of the speed. First, tell me about the components of the speeds. So, sir, the first component is here and the second component is here. Ante kada? If this angle is theta, andariki observe cheskondi. If the angle with the horizontal is theta, you can simply say this component is going to be okay. So this component is going to be u cos theta, andariki ardham cheskondi, and this component will be u times sin theta. Ante kada? Yes. So these are the components. Chuskondi. Now, in the horizontal, there is no force. Ante, no acceleration. That means the speed u cos theta will remain the same. Are you understanding? Yes. So, ante, if you are talking about the horizontal speed, I will write it with this blue color. Chuskondi. Here also, it is same u cos theta speed. Here also, it is same u cos theta speed. Here also, topmost point lo kuda same speed u cos theta, and mottam points lo horizontal speed is same as u into cos theta. Ante kada? Here also u cos theta. Finished. Remember point number 1 Point number 1. the horizontal speed of the projectile always remains the same and u cos theta. Okay, the horizontal speed always remains the same as u cos theta. Ante kada? Good. What about the vertical ray? Okay, so let us write vertical speed with this color or red color, not red ray, white color. Okay, cheppandi ra. Initially it was u sin theta. Initially ra, initially. Kani it is changing with time kada? Why re? Good, Bhanu, very good, very good, very good. But it is changing re. Why? Endukante gravity is acting in the downward direction. Are you understanding? Ante vertical low you can tell at any general point t ra, after time t re, hey, time t tarvata ra, Vx is equals to u cos theta. No force horizontal low, ante no speed change. Vy is changing, but it is only changing in the vertical. It will not have any impact in the horizontal direction. Ante kada? Yes. So vertical Vy is equals to, hey, you throw the ball upwards with a speed u sin theta. Ante kada? U sin theta, u sin theta. But at the same time, g is also acting. So sir, v is equals to u plus 80. V is equals to u plus 80. U is u value is u sin theta. Acceleration is minus g into t. Chuskondi. V is equals to u plus 80 form. So ante, what can you say about time ray? Now I want you to take to the total time of flight ra. Chuskondi. Total time of flight. If I have an object, hey, chuskondi re, kinematics 1D lo nenu already cheppanu andariki. Okay, already I told you, if you are throwing an object with speed u ray, it will go up and it will come down and it will take total time is equals to 2u by g. Gurdunda, I told you when I will explain 2D, I will only give you the reference. And I gave you the reference. Ante kada? Yes, I gave you the reference from kinematics 1D. It is there. What is there? From kinematics 1D, you should remember the time is 2u by g. Ante compare it with this projection. This speed was u ray, right? This speed was u, and there were two different components. First, second. This was u sin theta. Ante kada? Yes. This and this are same. Chuskondi. Same. These two are same. Endukante they are having same speeds and same acceleration due to gravity. The only thing is that it is u here and u sin theta is there, but at the same time they are actually performing the same motion. Ante total time is equals to 2 into u. Instead of u, it is what? 2u sin theta. Oh, okay. So 2u sin theta divided by g. Ide na time of flight ra. Andariki ardham cheskondi. So ante 2u sin theta by g, ఈ time తర్వాత the particle will go up and come down, go up and come down, go up and come down. అంతే కదా? The only change is that this u cos theta is dragging the particle in the right side. అంతే కదా? Good. సో ఇప్పుడు రేంజ్ గురించి మాట్లాడతాం. చూసుకోండి. టైం గుర్తుపెట్టుకోండి. టైం ఈజ్ 2u sin theta divided by g. అంతే కదా? సో ఇప్పుడు రేంజ్ గురించి మాట్లాడాలంటే I want you to bring back to this slide ra. Time constraint. What is time constraint? In the same time the ball is going up and coming down. In the same time the particle is also moving, right kada? Yes. So if it is taking 5 seconds ra, hey, 5 seconds to come up, 5 seconds to go down, and at 10 seconds, if it is taking 10 seconds to complete up and down, those 10 seconds will be taken to move to the right. Ante kada? So this distance ra, speed into time ante kada? Endukante no acceleration, speed remains same. Speed same unte distance is equals to speed into time. Ante. So here the object was thrown something like this ra. Chuskondi. So it took the total time 2u sin theta by g, hey, to go up and to come down. But in the same time only the particle move up in the forward direction, right? Hey, in the same time only the particle also moved in the forward direction. Ante distance is equals to speed into time. Ante kada? Speed gurinchi cheppora. So if my net speed was u this was u cos theta and this was u sin theta. Ante kada? Hey, horizontal ray. Distance is equals to speed into time. Cheppandi, what is speed ray? Horizontal, what is speed ray? Sir, distance is equals to speed is u cos theta multiplied by time ray. What is time ray? Time to go forward is equals to time to go up and come down. Ante 2u sin theta by g. అర్థమైంది? సో ఇక్కడ నుంచి యూ కెన్ సింప్లీ సే రేంజ్ ఇస్ ఈక్వల్స్ టు యూ ఇంటూ యూ. యూ స్క్వేర్ రా. వాట్ ఈస్ రిమైనింగ్ రా? 2 sin theta cos theta. 2 sin theta ఇంటూ cos theta డివైడెడ్ బై g. అంతే కదా? ఎస్. కానీ 2 sin theta cos theta ఈజ్ cos 2 theta రా. అందరికీ అర్థం చేసుకోండి. డివైడెడ్ బై g. సో దిస్ ఈజ్ మై రేంజ్ రే. Hey, that was my time. That is my range ra. Hey, this is my range ray. Now, when you have height of the projectile ra, చూసుకోండి. Again, I am taking you back in the kinematics 1D. If I am throwing the object in the vertically upward direction with a speed of u ra, చెప్పండి, the maximum height it will attain is h is equals to u square by 2g. అంతే కదా? ఇక్కడ u ఉంటుందిరా. అండ్ వెన్ యూ కంపేర్ ఇట్ విత్ ద ప్రోజెక్టైల్ రే, చూసుకోండి, వెన్ యూ కంపేర్ ఇట్ విత్ ద ప్రోజెక్టైల్, అదే ద వాల్యూ ఆఫ్ u ఓన్లీ చేంజెస్ రే. సో ఇట్ ఈస్ మై u, దిస్ ఈజ్ మై u కాస్ థీటా అండ్ దిస్ ఈజ్ మై u సైన్ థీటా. అంతే కదా? చెప్పండి. సో దిస్ ఈజ్ u, దిస్ ఈజ్ u సైన్ థీటా. సేమ్ ప్రాసెస్ సార్, సేమ్ గోయింగ్ అప్ అండ్ సేమ్ కమింగ్ డౌన్. ఓన్లీ థింగ్ ఈజ్ హియర్ ఈజ్ u, ఎక్కడ u సైన్ థీటా ఉంటుంది కదా. ఎస్. సో హైట్ ఈజ్ ఈక్వల్స్ టు u స్క్వేర్. u స్క్వేర్ అంటే మొత్తంకి స్క్వేర్. చెప్పండి, u స్క్వేర్ అంటే u sin theta హోల్ స్క్వేర్ డివైడెడ్ బై 2g. అంటే హైట్ ఈజ్ ఈక్వల్స్ టు u స్క్వేర్ sin స్క్వేర్ theta డివైడెడ్ బై 2g. అంతే కదా? ఎస్. చూసుకోండి, ఐఎమ్ రైటింగ్ ద క్విక్ రివిజన్ ఫార్ములా లిస్ట్ రా. వెరీ, ఇఫ్ యు ఆర్ అండర్స్టాండింగ్ దిస్, వెల్ అండ్ గుడ్. ఇఫ్ యు ఆర్ నాట్ అండర్స్టాండింగ్ దిస్, very good. Okay, but remember the formulas. Are you understanding? Okay. So if I am throwing this ball something like this, it is going and hitting the ground. Ante kada? So ee horizontal distance ni r ante range pilustaru. This maximum height h and the total time is t. Ante kada? 3 ఫార్ములాస్ రాస్తున్నాను, చూసుకోండి. ద ఫస్ట్ ఫార్ములా ఇస్ టైమ్ ఆఫ్ ప్రొజెక్టైల్ అంటే 2u sin theta డివైడెడ్ బై g. సెకండ్ రా, చెప్పండి, రేంజ్ ఆఫ్ ద ప్రొజెక్టైల్ ఇస్ u స్క్వేర్ sin ఆఫ్ 2 theta డివైడెడ్ బై g and maximum height attained is u square sin square theta divided by 2g. అంతే కదా? Remember these formulas రే. You can write it and you can note it down, but remember, I want all of you to remember the formula. Okay, good. చెప్పండి అందరికి. నెక్స్ట్ లెట్ us talk about a question రా. చెప్పు. 20 meter per second, 45 degree with the horizontal, find time of flight, find range, maximum height attained by the projectile. చెప్పు. So first, sir, time formula is 2u sin theta divided by g. Substitute the values రా. చెప్పండి. So 2 into the value of u is how much రే? 20 కదా, into sine of theta is how much ray? Theta is 45 degrees divided by g is 10 ray. Hey, g is 10. Ante kada? So the time total it takes is 20 by 10 into sine 45 is 1 by root 2 ante 2 by root 2 ante root 2 seconds. పాయింట్ నెంబర్ 1 అయింది కదా. సెకండ్ రా చెప్పు, నాకు హైట్ కావాలి. హైటా? ఎస్ హైట్ చెప్పండి. మ్యాక్సిమం హైట్ ఫార్ములా ఏంటిరా హైట్కి? యూ స్క్వేర్ సైన్ స్క్వేర్ థీటా బై 2g. యూ స్క్వేర్ని వాల్యూ పెట్టుకోరా. 20 స్క్వేర్ అంటే 400 కదా, ఇంటూ సైన్ స్క్వేర్ థీటా అంటే సైన్ స్క్వేర్ 45 అంటే 1/√2 హోల్ స్క్వేర్ అంటే 1/2 డివైడెడ్ బై 2g అంటే 20 అంతే కదా. సో ది 0 0 గాన్ రే. 1/2/2 4 అంటే ఓన్లీ 10 మీటర్స్ ఆఫ్ హైట్ ఇస్ ఇట్ అటైనింగ్. అండ్ లాస్ట్లో చెప్పండి రేంజ్ గురించి ఫార్ములా చెప్పురా. యూ స్క్వేర్ ఇంటూ సైన్ ఆఫ్ 2 theta రే, 2 theta డివైడెడ్ బై g అంతే కదా. సో యూ స్క్వేర్ ఇంటూ యూ స్క్వేర్ ఇస్ హౌ మచ్ రే? 20 స్క్వేర్ రే. సో ఇట్ ఇస్ 400 ఇంటూ సైన్ 2 theta అంటే సైన్ ఆఫ్ 2 ఇంటూ థీటా. థీటా ఇస్ హౌ మచ్ రా? 45 degrees కదా, డివైడెడ్ బై g is 10. సో gone. You are only left with 40 meters of range అంతే కదా. Yes. So now I want you to show a simulation. Good. So let us talk about a simulation. Okay, so let us take the values ra. Okay, so let us say I have an object. Hey, angle cheppora. What angle should I take? Speed. What speed should I take? What speed should I take? What angle should I take? Automatically it will get converted. Okay, so let us take the angle to be 45 degree. Andariki cheskondi 45 degree angle is there ra. Let us say speed is equals to 40 meter per second is the speed ra. Chappu range ki formula cheppandi. Sir, range is equals to u square sin of 2 theta divided by g ante kada. U square ante how much re? 40 square ra. So 40 square into sin of 2 theta re. 2 theta ante 2 into 45 degrees kada. Yes, so 2 into 45 degrees divided by g is 10. చూసుకోండి. So it is equals to 40 square re 1600 kada into sin of the values are getting too much. So let us do one thing. Okay, let me change the values of the initial speed. Okay, I am changing the value only re. ఎందుకంటే the simulation I have to see. Okay, so let us say let us say u is equals to 10 meter per second. చెప్పండి ఇప్పుడు చెప్పండి. So range is, sir, r is equals to u square sin of 2 theta divided by g అంతే కదా. u square అంటే 10 square రా, 100 into sin of 2 into theta అంటే 2 into 45, sin 90 is 1 anyhow divided by g is 10 కదా. sin 90 is 1 రే. So it is 100 by 10 అంటే 10 meters of range I am getting రా. చూసుకోండి అందరికి. How much range am I getting రే? 10 meters. Very good. Sriram, 160 meters was the answer in the previous case. కానీ ఇక్కడ the range is 10 meters అంతే కదా. గుర్తు పెట్టుకోండి వాల్యూస్ రే. స్పీడ్ is 10, యాంగిల్ is 45 అంతే కదా. స్పీడ్ is 10, యాంగిల్ is 45. ఇప్పుడు we'll see if our answer is matching or not matching. చూసుకోండి. This is my simulation అంతే కదా. It's visible to all of you రే. Is it visible? చూసుకోండి. This is the Canon. Okay, this is a Canon. I can set the angle. Okay, I can set the angle. Here it is my target. I can move it back and forth. Understanding. So let us do one thing. Let us take the value of g as 10 ray. Great. చూసుకోండి. What is the initial speed? 10 meter per second kada. Yes. So the initial speed is 10 meter per second. అందరికి చూసుకోండి. And the angle is 45 degrees kada. So it is 50, 44. Here it is 40. 46, not 46 re. 45. Alright. Good. Hey, what was the range coming re? Range was coming out as 10 meters kada. 10 meters ki range ra. Hey, I will set this to 10 meters ra. Chuskondi. It is 20 now. It's 20 now. Now it will become 10 ra. Hey, it is now coming to 10 kada. 10.5, 4, 3, 2, 1, 10 only. Hey, not 10.1, 10. Hey, value set అయింది. చూసుకోండి అందరికి. Everything is set కదా. Now I am going to shoot it. Now I am going to shoot it. చూసుకోండి. Done. Yes. Understanding? Understanding? Hey, tell me some other values, Ray. Tell me some other values. Cheppora. Tell me some other values, Ra. So tell me some other values. I'll take some more values, okay? Okay, I'll take some more values, Ra. So let us say, cannot write over here, right? Can't write it. Okay, I can't write it. So let us do one thing. Let us shift to our own problem, Ra. Chuskondi. Okay, now I'll change the values, okay? I'll change the values, Ra. Cheppandi. So instead of 10, I am taking the initial speed u is equals to 20 meter per second and the angle is theta is equals to 45 degrees. Cheppandi, what is the formula for the range, Ray? What is the formula for the range? Cheppandi andariki. What is the formula for the range? Sir, range is equals to u square sine of 2 into theta divided by g. Ante kada? U square ante how much, re? 20 square ante 400 into sine of 2 into 45 is 90 divided by 10 ante 40 meters of height is there. Range, range. 40 meters of range, ante kada? Yes. Let us do the same thing now. Okay? Let us do the same thing now, Ray. So what I am doing is, I am changing the range to 40 meters. Ra. Possible, not possible? Not possible. Let us zoom it out a little. Okay, so range now, it is going to be 40 meters. Ra. Hey, chuskondi. Speed, Ray. Speed is 20 meters per second. Kada? Yes, so the speed is 20 meters per second. Good. 45 degree angle. Angle is the same. Chuskondi andariki. 45 degree angle. Ra. Angle is the same. So now, I will shoot. Hey, nice. Getting it. Hey, height gurinchi cheppora. What is the height it attained? Time and height. Cheppandi andariki. What is the time? What is the height? What is the time? What is the height? Hi, Kanmani. Hi. Height gurinchi maatladalante, let us take the height, Ray. Chuskondi. So this is my meter scale kada. So what I am doing now is, I am taking the maximum height. Chuskondi. Maximum height is how much, Ray? Hey. How height is how much, Ray? Approximate 8.5 kada. 8.5. Let us calculate the height from our formula, Ray. Cheppu. Height is u square sine square theta divided by 2g. Ante kada. U square ante how much, Ray? U square is 20 square ante 400 multiplied by sine square theta. How much, Ray? Sine square 45 ante kada. Sine square 45 divided by 2g is 20. So ante it is 400 into 1 by 2 divided by 20. Ante kada. This is my maximum height, Ray. Chuskondi. So approximately height entara? Height is approximately equals to 10 meters. Okay, how much we are getting, Ray? Hey, how much we are getting, Ray? Okay, let us do one thing. It is the highest point. This should be my mark, Ray. Okay, this should be my mark. Chuskondi. Exactly how much, Ray? 9.9 meters kada. Same, approximately equal to 10 meters per second. Okay, height is 10 meters. Okay. Now, let us do one more thing, Ray. One more time, and then we will be moving towards next. Chuskondi. So it is my speed. Hey, u is equals to 30 meters per second. Hey, 30 meters per second. Now I am taking a general angle, Ra. Cheppo. 30 degrees. Ante kada? Tell me the value of range, Ra. How much range should it be? I have said the same values. I will be coming back in 5 minutes. Okay? Just in 2 minutes. Not 2. Cheppandi andariki. Range gurinchi cheppandi. After that, I will set the same values. Let's see. Cheppu andariki. చెప్పండి అందరికి. నాట్ డన్. చెప్పండి అందరికి చెప్పండి. డన్ నాట్ డన్ రైట్? డన్ ఆర్ నాట్ డన్? వాట్ ఈస్ ద రేంజ్? వాట్ ఈస్ ద రేంజ్? 40/√3. √3 వాల్యూ అప్రాక్సిమేట్ తీసుకోండి అమ్మా. సో సార్ ఓకే చూద్దాం రా. చెప్పు సార్. రేంజ్ ఈజ్ ఈక్వల్స్ టు u² ఇంటూ సైన్ ఆఫ్ 2θ డివైడెడ్ బై g. u² అంటే హౌ మచ్ రే? 30² ఇంటూ సైన్ ఆఫ్ 2θ. 2 ఇంటూ θ అంటే 60 degrees రా. డివైడెడ్ బై g is 10 అంతే కదా. సో 30² is 900 ఇంటూ చెప్పండి సైన్ 60 is √3/2 కదా. ఎస్. సో ఇట్ ఈస్ √3/2 divided by 10. 0 0 gone రే. అరే 90 ఇంటూ √3 డివైడెడ్ బై 2 అంటే 40/√3. √3 వాల్యూ రా తీసుకోండి. అప్రాక్సిమేట్లీ ఈక్వల్స్ టు 1.7 రే. సో 45 ఇంటూ 1.7 అంతే కదా. 874. దిస్ ఈజ్ మై రేంజ్ రే. హైట్ గురించి చెప్పురా. హైట్ హౌ మచ్ రే? హైట్ ఈజ్ ఈక్వల్స్ టు u² sin² θ డివైడెడ్ బై 2g అంతే కదా. u² వాల్యూ రా. u² is 30² అంటే 900 ఇంటూ sin² θ అంటే sin² 30 రా. sin² 30 చెప్పండి అందరికి. sin² 30 is how much? 1/2 1/4 divided by 2g is 20 అంతే కదా. ఐఎమ్ డూయింగ్ ద క్యాలిక్యులేషన్స్ డైరెక్ట్లీ రా. సో ఇట్ ఈస్ అప్రాక్సిమేట్లీ ఈక్వల్స్ టు 90/8 అంతే కదా. సో యూ కెన్ సింప్లీ సే 11 రే. 11.125 అంతే కదా. హైట్ ఇస్ దిస్, రేంజ్ ఇస్ దిస్. ఐ హోప్ ఇట్స్ క్లియర్ టు ఆల్ ఆఫ్ యూ. So let us do also re. Let us verify re. Speed is 30 74.5 kada. Yes. So 30 74.5 re. Hey, speed is 30 also re. Angle is also 30 ra. Okay. Range is how much re? 74.5 kada. Yes. So I'll wipe out everything first. So let us take range as 74.5. Are 6 not 6 right? It's not 6. Finished. Good. అర్థమైంది అందరికి. Shall I fire now? అరే you also move రే. Also not useful. Okay, shall I fire now? అందరికి చెప్పండి ఒక్కసారి. Let us see. Okay, 3 2 1 done. Oh, it did not hit ray. 74.5. Answer is wrong. Steps are wrong. Everything is correct. 76 ray. The calculation is correct ray. Choose it should be 76.5. Okay, 76.5. 17.5, 85, 85, 8 is carried. 0.5 I have written here. 17 into 4, 68. 68 plus 8 is 76. So let us do one thing again. Let us take the range as again Mallira 76.5. Okay, 76.5. Good. Now I'll shoot. Yes. It hit అయింది కదా. Yes. Good. అర్థమైంది. హైట్ గురించి మాట్లాడతాం రా. సో లెట్ us see. Are you able to see this green point రే? Are you able to see this green point? So I'll start from this green point. చూసుకోండి. I will start from this green point. Okay, let us shift it. Let us bring it again. Okay. వాట్ ఈస్ ద హైట్ వీఆర్ గెటింగ్ రే? 11.125 కదా, చూసుకోండి 11.125 meters of height we are getting రే. I'll try to match it. Okay, 11.125 meters చేసుకోండి. You shift it a little down so that it comes on the height only, and you shift it a little down. 11.125. Hey, understand రే, almost similar height. Okay, good. So ఇప్పుడు we will move to our low. Simulation అయిపోయిందిరా. Okay, simulation is gone now. చూసుకోండి. So let us take UIQs now. చెప్పండి అందరికి. minutes are more left. చెప్పండి అందరికి చెప్పండి. I'm giving you 30-40 seconds of time ra. You do this and you tell me the answer ra. చెప్పండి. So not telling the answers ray. Why are you so much good? A. Okay sir, 20 meter per second velocity గురించి మాట్లాడుతున్నాం కదా. Yes, so this is my object. Initial speed is 20 meter per second, ante kada. So you resolve ray, you resolve into components ra. The first component will be in the right side, second will be in the upward direction, ante kada. Yes, angle gurinchi cheppora. Angle is 60 degree kada. Yes, so this will be 60 degrees of angle ray, ante this will be u cos 60 and this will be u sin 60. So u is 20 into cos 60 is half, ante 10 meter per second. Okay, this is the horizontal speed ray, initial horizontal speed. చూసుకోండి అందరికి. అరే so when the projectile is at the highest point here, అక్కడ చూసుకోండి రా, it is at the highest point ante vertical speed is 0. అదే that only means it is at the highest point. Understanding? So Vy is equals to 0 ra, at the highest point. అందరికి అర్థం చేసుకోండి. And horizontal speed is not changing at all kada. So it will only have a horizontal speed of u into cos theta at the highest point ante 10 meter per second. Next, తీసుకోండి. Arey, remember the values ray. Okay, 280 meters per second, 30 degree above the horizontal. Okay, maximum height attained. Height గురించి ఫార్ములా చెప్పండి రా. Height is equals to u square sin square theta divided by 2g, అంతే కదా. u square values పెట్టోరా. So it is 280 squared into sin square 30. Sin 30 is 1 by 2 కదా. So sin square 30 is 1 by 4 ra. Hey, 1 by 4 divided by 2g is 2 into the value of g is 9.5. 9.8 రే. 9.8 అంతే కదా. 28 square. 28 square. చెప్పండి అందరికి, what is the value of the square of 28? Okay, so I think it will be around 00, 00 are there, 4, 784 kada, yes, into 1 by 4 divided by 2 into 9.8. So 8 gone, you can also divide it by 8. So 8 9s are 72, 6 is remaining, 8 8s are 60, 00 divided by 9.8. Gone. Maximum height. Next, చూసుకోండిరా, cricket ball is thrown by a player 20 meter per second, 30 degree above the horizontal. Maximum height, again same formula, same formula, h is equals to u square. Let us do one thing, okay, let us try to do it in simulation first, దాని తర్వాత we will solve the question. Okay, speed 20 meter per second, 30 degree, okay, 20 meter per second, 30 degrees ra, remember, okay, 30 degrees, speed is 20 meter per second ra. Okay, 20 meter per second. I'll send it here only. Okay, let us fire. Okay, this is the highest point. Hey, this is the highest point. You take it to this point, you take it to this point, okay, you take it to this point and try to calculate it. It is approximately equals to 5.02, okay, 5.02. Hey, approx range ra, hey, 5 meters only, it's there, it's there, 5 meters only. Cheppandi. So I square is equal to u square into sin square theta. Sir, what is that tool, sir? Sir, we will take that in NEET examination only, sir. We will take our mobile. We will do this experiment. We will get the value of range, height, divided by 2g ra. Cheppo. U square ante initial speed ra, 20 square, 400 into sin square theta ante sin square 30 ante 1 by 4 divided by 2g ante 20. So it is 100 divided by 20 is equals to 5 meters. Ante kada? Cheppandi ra. What are you saying, re? Good. Aro, very good. Very good. Next. Oh, NEET 19, re? NEET 2019 ante kada? Cheppandi andariki. So when an object is shot at 60 degrees with horizontal, travels a distance of x1 ra, along the plane, but 60 degrees, 60 ya, 30 re, I don't know re, I think some typing mistake is there. They can't be 60 at the same time. You take 30 re, 30 తీసుకోండి. And I don't know if value is also 30 or it is 60 only. So let us see if it matches or it does not match ra. Cheppandi andariki. 60 degrees, x1 distance, 30 degrees, x2 ra, same speeds. Cheppandi. Range is equals to u square sin of 2 theta divided by g. Kada? Yes. So r1 is equals to, same speed is there, ante u and g are same. Sin 2 theta 1 divided by r2 is equals to u square sin of 2 theta 2 divided by g. Ratio తీసుకోండి రా, r1 by r1 re, r1 by r2 re, r1 u square gone, g gone, ante sin of 2 theta 1 divided by sin of 2 theta 2. చెప్పు అందరికి. సో అంటే sin of 2 into theta 1 value ఏంటి రా, theta 1 is 60 degrees, theta 2 is 30 degrees, ante kada. So 2 into 60 divided by sin of, cheppandi, 2 into 30. So it is sin of 120, sin of 120 divided by sin of 60. What is the ratio re? 1:1 kada. ఎందుకంటే sin 120 is root 3 by 2, అందరికి అర్థం చేసుకోండి. And it is also root 3 by 2 kada. Yes. Where is it getting mistake kada? Ranges kada. Where? Sin 120. Gone re. 1:1. Options are not matching. ఎందుకంటే this value is not matching ra. Okay, so if it is 30 degree, you take the ratio as 1:1. Okay? A similar question, not exact NEET question, it becomes a similar question then. Alright, next try. Oh, nice. Nice. Cheppandi. Find the angle at which object should be thrown such that at a given speed, range is maximum. Alright, range formula. Range is equals to u square sine of 2 theta divided by g. Ante, I want angle kada, so I want sine 2 theta. Sine 2 theta ante, it should be maximum. Range maximum kavalante, sine 2 theta should be maximum kada. So sine 2 theta should be maximum. Maximum value of sine 1. At what angle? 90 degrees. So that means 2 theta should be 90. Ante theta is equals to 45 degrees. Andariki ardham cheskondi. It is the sole point of 45 degree at which you get the maximum range. Then tarvata you change the angle, even if it seems that you are throwing at a low angle, sir, it will go more fast. If you are increasing the angle, sir, there is chance that it will go up and come cover a low distance. Gurt petkondira. At theta is equals to 45 degree only, you get the maximum amount of range. Ardhamindi. Let us do the experiments also. Chuskondi. So, ide na preparation mode. Okay, I am wiping everything. Okay, so you also go there. I don't need you. Okay, so let us say 30 degree angle is there. Okay, I am increasing the speed to 30 meter per second. Chuddam. Should I fire? Should I fire? Should I fire? Okay, I am firing it. Chuskondi. No, I will reduce the speed. I don't have that much of range only. So let us say 20 meter per second. I am firing now. Chuskondi. This is my range. First range. Same speed. Only I am increasing the angle to 45 degree. Andariki ardham cheskondi. 45 degree. Ante kada. Fire again. This is my range. Increase. Again I will increase the angle. Chuskondi. So let us say from 45, I am making the angle to 60 degrees. So angle is 60 degrees now. 60 degrees now. Okay. Again I will fire. See. Oh. Ante endira. Chuskondi. Maximum range for 45. Yedina angle teeskochu. You increase the angle or you decrease the angle. I don't care. But the range will always be less than the given range. Endukante chuskondi. Are you able to understand? The maximum range is only for the 45 degree angle. You reduce it, fire it. See. Are you able to understand? Okay, good. One more thing I want to show you. Chuskondi. So let us take the angle to be 28 degrees, 29 degrees. Ante kada? 29 degrees. Theta is equals to 29 degrees. Range chuskondi andariki. So ide na range. Now I want to change the value of angle theta. Initially I took the angle theta 1 is equals to 29 degrees. Now I want to change the angle. Let us take another angle theta 2. Kani, I want to take a special value. What special value, sir? You take theta 2 is 90 minus theta 1. 90 minus theta 1. Cheppandi. 90 minus 29 is how much? 61. 61 degrees. So let us take the angle as 61 degrees. Andariki chuskondi. Ippudu I am taking the angle as 61 degree or not 3. 61. Okay, good. Fire. Something similar. Oh. Ante range is same. That means for 29 and 61 range is same. Coincidence, is it coincidence? Let us see. Okay, let us see. I will change the value of angle now. Random angle, okay, random angle. 40 degrees. Hey, random angle 40 degrees. Fire. Now I will change the value of angle to 90 minus this 40 degrees. 90 minus 40 is 50 kada? Okay, let us take the angle as 50 degrees. Let us take the angle as 50 degrees. Not 48. Okay, good. 50 degrees. Speed is same, okay? Speed is same. I am not changing the speed. Speed is same. Fire cheskondi. 50 meters. 40 50 అంటే what are you getting రే? What conclusion are you getting రే? చూసుకోండి. So if theta 1 is equals to 40 degrees, theta 2 is equals to 50 degrees, range is same. If theta 1 is 29 degrees and theta 2 is equals to 61 degrees, range is same. Cheppandi, if I say theta 1 is equals to 33 degrees, what should be the value of theta 2 for the same range ray? For the same range ray, 57. Oh, nice. Same range. Understanding? Ante, if you have two different angles and they are complementary ante their sum is 90 degrees ra. Chuskondi. Finished. Ante kada. Good. Now let us move to the next question. Chuskondi. Okay. Find the angle with the horizontal at which object should be thrown such that at a given speed height at its maximum. Height maximum ra. So ante h is equals to u square sin square theta divided by 2g. Angle kavali kada. So angle ante sin theta. Height should be maximum. Ante sin theta should be maximum. Sin theta is maximum at 90 degrees. Ade. So that means theta must be equals to 90 degrees ra. Chuskondi. If theta is 90 degrees re. Here I'll wipe out everything. Height gurunchi cheppandi. You maximum height re. Hey, this is my maximum height kada. Now I'm increasing the value of angle as theta as 90 degrees. Cheppandi. Firing again re. This is my maximum height. You take any other angle ra. You take any other angle. Maximum height is less than this only. Okay. Maximum height is less than this. Okay. See, this is the maximum height. At what angle? Theta degree. 90 degrees. At 90 degrees you get maximum height. At 45 degrees you get maximum range. Ante kada. Remember these results. Very important results. Okay. Very important results. Andariki ardham cheskondi. Now let's come back to our discussion. Okay. Do we have something to discuss? Yes. Oh, NEET 2014. Sir, NEET 2014. What does the question say? What does the question say? Chappu andariki. Okay. So sir, projectile fired from surface of earth 5 meter per second, theta. Okay, theta. So sir, this is my earth. This is my planet ray. Hey, general planet ra. Chuskondi. So earth lo, I'm throwing this angle, projectile 5 meter per second ra. What is the angle ray? Angle is theta. It will go up and come down. Ante kada? Yes. Similarly, sir, on the planet also, I am throwing this object. Kani speed chosukundira andariki. Speed is 3 meter per second on the planet ray. On the planet, speed is 3 meter per second. Angle ray with a speed of same angle. Chuskondi, same angle. Ante kada? So idi kuda theta. And it also follows the same trajectory. Same trajectory ante same range, same height. Same range, same height. Are you understanding? So ante range R1 and range R2, they are same. Are you understanding this? Okay, and I want to calculate the value of, what do I have to calculate this? Okay, value of G on the planet ray. Here, this is G on earth. What is the value ray? 9.8 on earth. Kani planet lo, I have to find the value of G. Cheppandi. R1 is equals to R2. Ante R1 is U1 square sin of 2 theta 1 divided by G1 should be equals to U2 square sin of 2 theta 2 by G2. Where U is theta is same ray. Hey, theta 1 theta 2 is same ra. Where it is gone ray. They are same kada. So I'm cancelling out. Ante sir U1 square by G1 is equals to U2 square by G2. Oh. So from here, sir, G1 by G2 is equals to U1 square by U2 square. Ante kada? G1 is, let us say, acceleration on the planet of Earth. Hey, planet of Earth. So it is equals to 9.8 divided by G on some random planet is equals to U1 square. u1 earth చెప్పు 5 square అంటే 25 divided by u2 square is 3 square అంటే 9 అంతే కదా. So you can simply say sir gp is equals to g on the planet is equals to 9 by 25 into 9.8. Are you understanding? Simplify it. Okay, do the simplification by yourself. Okay, last part, equation of trajectory. We do have some time and I think we can discuss the equation of trajectory also. Cheskondi. If this is my thrown projectile, angle of the projection is theta, initial speed is u ray, what can I write about the maximum height ray? Cheppo, maximum height h kada. But I want to write this maximum height in terms of equation of motion. S is equals to ut plus half at squared. Ante kada? Yes. So sir, h is equals to ut ante vertical speed ut plus half a t squared. What is a ray? What is a ray? What is a ray? Right? What is a ray? What is a ray and what is t ray? What is t? Cheppandi andariki. What is t? So sir, sir t is 2u sin theta by g. Mottam time t kada, total time t ray, but I don't want total time, I want half of the time only to go up ray. Cheppandi. So total time t is equals to u sin theta by g ante 2u sin theta by g is total time, but I only want the time to go up, half of it, u sin theta. Uy, what is the value of uy ray? Uy value cheppor andariki. Uy value is also equals to what should I say now, sir? Sir cheppu. Uy is u into sin theta. Ante kada. Chalo. So sir, height is y kada. Sir, what should I say, sir? You can simply say time ray, time. అంటే sir, if this is my distance x, చూసుకోండి రే అందరికి చూసుకోండి, this is my distance x, can I say x is equals to u into cos theta, distance is equals to speed into time kada? Yes, you can say that. So from here sir, I'll get t is equals to x divided by u cos theta. Oh, great. Array, lift, shift, substitute, cheppo. So y is equals to uy ray, uy ante u sin theta multiplied by time t ra, time t is x divided by cos theta minus, enduku minus sir? Because speed is in the upward direction and acceleration in the downward direction. Chuskondi, acceleration is negative ra, minus half into acceleration is g ray into t square ante x divided by u cos theta whole square. Simplify chesi, you get the equation of trajectory as y is equals to x tan theta minus gx square divided by 2u square cos square theta. So this is the equation of trajectory. See it ray. Okay, you can observe it. X divided by u cos theta ante kada, u gone ray. Sin by cos is tan, x tan theta minus g into x square by 2u square cos square theta. Equation of trajectory, remember it, very important. Okay, initial velocity of this, equation of its path 3, aims 2017. Cheppandi andariki sir, not v, sir, u bar is equals to I cap plus 2j cap ante kada. Can I say about angle ray? What can I say about angle ray? Now you want to find the angle ray. Chuskondi. Sir, first of all I will try to calculate the value of the magnitude of the speed first of all. So sir, if u bar is this, magnitude of u is root of 1 square plus 2 square ante root 5. Point number 1. Ippudu chuskondi, 1 in the right side and 2 in the y direction ante cheppandi ra, this angle ray, theta. So sir, if it is 1, it is 2. By Pythagoras theorem, this comes out to be root 5. Ante kada? Yes. Cheppandi. What do I need? Formula re. Hey. Formula lo you need tan theta, you need cos theta. Calculate cheskondi. So tan theta gurinchi maatladite opposite by adjacent. Sir, tan theta is equals to 2 by 1 and cos theta is adjacent side by hypotenuse. Ante 1 by root 5. Ante kada? Yes. Lift, shift. Sir, equation of projectile is y is equals to x into tan theta minus gx square by 2u square into cos square theta. Ante x is x, tan theta value re 2 by 1. 2 by 1. Array, not visible re 2 by 1 minus g is given to you. Take g as 10. Okay, take g as 10 ra. So 10 into x square divided by 2 into u square re. Array, u is root 5. So u square is 5 into cos square theta re. Cos theta is 1 by root 5. Cos square theta is 1 by 5. It will come up kada. So it is 1 by 5. Ante. So 5 gone re. This is 5x square only. Chuskondi. So the equation is coming as y is equals to 2x minus 5x square. Sir, option C is correct. I hope it's understandable, not going out of your brain. Okay. So let us take one more question and let us finish this session. Too much headache. Huh? Is it getting too much headache, sir? Why are you discussing all these things, sir? We are not interested at all, sir. Okay. Okay. Okay, Parimala, okay. Okay. I'll give you one question. Let us see. Should I keep NEET level only? JEE Mains level? JEE Advanced level? Okay. I'll try to give it. Okay. Hey, I could have made difficult also. Instead of this angle of projection, if you are done with this question, find the ratio of maximum heights. You can change with this also. Okay, the question becomes a little lengthy. Ante. It's a random question I made and random question I gave you. Okay. So how many of you can solve it? Yeah, Hemant Kumar, I'm fine. I'm absolutely fine. Give me 1 minute. Oh, Arav, very good. 1:3. I don't know, Ray. I don't know. Okay. No, Kanmani, no. I did not skip any messages, Ray. Okay. Chuddam ra. So, these are my projectiles, Ray. Okay, separated by distance d. First, second, ante kada. So it is sitting here, not here, right? D by 4 ante somewhere here, and it is hitting somewhere here. But they are all hitting at the same time, okay? Same time, right? Something like this, okay? Something like this. This distance d by 4, and this automatically becomes 3d by 4, ante kada? Yes, ranges, right? Basically ranges, ra. You same speed kada? Same speed, ah? Hey, same speed, add it, right? Hey, same speed, right? So, sir, R1 by R2 is equals to u square sine of 2 theta 1 divided by g divided by u square sine of 2 theta 2 divided by g. U square, g gone, right? Sir, R1 by R2 is equals to sine of 2 theta 1 divided by sine of 2 theta 2 andariki observe cheskondi. R1 by R2 ra, d by 4 by 3d by 4 ante 1 by 3 is equals to sine of 2 theta 1 divided by sine of 2 theta 2. Very good. Remember, remember, if the angles are very small, chuskondi, if, I should write here, okay, let me change the ink. If theta 1 and theta 2 are small, so that means we can approximate, sir, sin theta is approximately equals to theta, ante kada? Yes. So that means 2 into theta 2 by theta 1, 2 into theta 1 by 2 into theta 2 is equals to 1 by 3 ante 2 2 gone, theta 1 by theta 2 is 1 by 3. Good, good, okay. But it is only valid when theta 1 or theta 2 are small. If they are not small, if they are good, big enough, we can't find the angles theta 1 by theta 2. Ante kada? Good ray, ray. Okay, okay, okay. No, 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 Kanmani, it's not in my hands, okay. Turning off the ads, it is not in my hands. అర్థమైంది అంటే chalo done. Maximum height ratio, the same thing, you can take sin square theta 1 divided by sin square theta 2 ante kada. It is h1 by h2. I'm directly writing ra, chuskondi. If you have to talk about heights, so h1 by h2 is equals to theta 1 square by theta 2 square, and theta 1 by theta 2 whole square, it is equals to 1 by 9. This could be the major question, okay. It is only valid if the angles are small. Good, good. Okay, so shall we end this session ra? Andariki cheppandi okkasari. I hope this session was helpful for you. It wasn't helpful, then watch again ra. Hey, if this wasn't helpful, watch again. Okay, 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 okay. Done, done, done. No, 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 no. Yes, 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 yes. K, 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 K. Yes, 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 yes. The next class tomorrow, same time. Okay, same time tomorrow. Same time tomorrow. Okay, done. Okay, andariki. Then good night, good night. Bye bye, bye bye, bye bye. Bye bye, bye. Done, Parimala done. Chalo, bye. Yeah, Joshna, when the next class will be tomorrow, okay? The next class is tomorrow only. Yeah, bye, bye, bye. Bye, Maitri, bye. Parimala, thank you so much. Thank you, Joshna. Good night, Nandini. Very good night. Thank you, Spandana. I hope so. Okay, bye, bye, bye. Kirlachari, bye. Yeah, Vaishu, Cheppu. What is the problem, Vaishu? Hi, Nandini. Cheppu, what? Yeah, you're saying something, Nandini? Time is 6 p.m. 6 p.m. Joshna, tomorrow time is 6 p.m. Okay, tomorrow time is 6 p.m. I'm not avoiding your texts. Okay, I'm not avoiding your texts. Okay, bye, bye, bye. Bye, Vaishu, bye. Thank you so much, Kanmani, bye. Yeah, Nandini, you're saying something. Nandini, you're saying something. Six p.m. Joshna, always 6 p.m. Okay. We'll start with. Let us do a poll, okay, on this channel about the next chapter. Okay, about the next chapter, we'll do a poll. It is there. It is there. It is there. It is there. Tomorrow the class is there. Okay, Andari. Chalo, bye, 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 all of you, bye. Arey, I can't see this button, right? Arey.